Hey guys, welcome back to our YouTube channel where we teach you AP Chemistry. You're here with Mahleej and Janiya. Let's unlock the secrets of chemistry one molecule at a time.
Every element leaves a fingerprint, and mass spectrometry reads it. In the last video, we talked about atomic mass and the mole, but here's a bigger question. How do scientists actually know the mass of an atom? The answer is mass spectrometry. It's basically a super precise scale for atoms, and it helps us identify elements and their isotopes. On the periodic table, the atomic number is the whole number at the top. That tells you the number of protons. The atomic mass is the decimal number at the bottom. That is the average atomic mass based on isotopes. But first, we need to define isotopes. Isotopes are atoms of the same element that have the same number of protons but different number of neutrons. Because neutrons add mass, isotopes have different masses, even though they're the same element. It's just like Mahleej when she has her medium iced matcha latte with cold foam from Dunkin' versus when she doesn't have enough money to buy one. Mahleej is still Mahleej, but she'll be in very different moods.
Don't start, Janiya. I just found out the Dunkin' near me is relocating.
Mahleej runs on Dunkin'. Another example is carbon always has 6 protons, but it can have 6, 7, or 8 neutrons. That gives us carbon 12, carbon 13, and carbon 14. Now let's talk about mass spectrometry. A mass spectrum is a graph that shows the mass, AMU, on the x-axis and the relative abundance on the y-axis. Each peak represents an isotope of that element. To identify an element, you look at how many peaks there are, which are the number of isotopes, the masses of those peaks, and which isotope is most abundant. If you see a spectrum with a huge peak near 35 AMU and a smaller one near 37 AMU, that's chlorine. Why? Because chlorine naturally exists mostly as chlorine 35 with some chlorine 37. That pattern is like an ID card for the element. The atomic mass on the periodic table is a weighted average, not a whole number. To calculate average atomic mass, multiply each isotope's mass by its decimal abundance and add all the values together. For an example, if you have an isotope A of 75% and 25% of isotope B, the isotope with the higher abundance affects the average more. So, mass spectrometry shows us isotopes. Isotopes explain why atomic mass isn't a whole number, and the periodic table pulls it all together. In the next video, we'll talk about pure substances, the law of definite proportions, and how to find empirical formulas.